All right, let's give this thing a try today. So we're moving into section 3 of chapter 10, which is looking at the gases. And in section 3, we're talking about the several gas laws that were established kind of in the mid to late 1800s. And the first one is Boyle's law. And the Boyle's law is related to the relationship between volume and pressure and how things change when those two either go, when one goes up, what happens to the other one. So the idea is, so the volume of a fixed quantity of gas, so we have a certain amount of gas and we aren't changing the amount of gas that's present, that's held constant, and so is temperature. Temperature is held constant, but the volume is inversely proportional to the pressure. What that means is that as the pressure goes up, the volume will go down, so the volume will get smaller. And as the pressure goes down, the volume will increase. Okay, so let's kind of look ahead. There's a better graph here. So an inverse relationship is volume versus pressure. Now, if we take 1 over P, so volume versus 1 over P, then we get a linear relationship. But so they are inversely related. And that should hopefully make sense, that as the volume of a gas decreases, the only way that that gas's volume will decrease is you have to increase the pressure if you hold the amount of particles and the temperature constant. So you get a relationship that PV is equal to K, or a constant in this relationship, if you're able to make this consistent graph. All right, the next relationship is called Charles' law. And Charles' law, he was the one that led us to eventually determine that there must be some temperature that you cannot get any colder than, which is where we get that's what absolute zero is, or absolute temperature comes from Charles's experiments with gases, because what he found, he was looking at the relationship between the volume of a gas and how it's related to temperature if you hold pressure and the amount of gas constant. So taking lots and lots of experiments, saw that as the temperature went down, the volume kept getting smaller, but with his Celsius scale, it looked like, he could keep getting colder. And so what he did is he, taking many measurements, extrapolated, well, what temperature would it have to get to that the volume of a certain amount of gas would equal zero? And that point where the volume of a gas would equal zero is what we call absolute zero, when basically all motion, all movement of particles, which gas pressure is related to movement of particles. If you have a balloon, you've got gases moving around, bouncing around, colliding on the inside, and technically the atmosphere colliding on the outside of that balloon. Well, as you get colder, okay, that volume is going to get smaller and smaller. So it's a linear relationship. As temperature goes up, volume goes up. As temperature goes down, volume goes down of a gas. The third relationship is related to what's called Avogadro's law, and this is the idea that the volume of a gas at constant temperature and pressure is directly proportional to the number of moles of the gas. And this is eventually where, like, if we have any gas at STP, standard temperature and pressure, if we have any gas at standard temperature and pressure, then it will be, if we have 1 mole of it, it will have a volume of 22.4 liters. And it doesn't matter if it is the heaviest gas in the world or the lightest gas in the world, you're still going to have those same values. It's going to be constant. And so it became this direct relationship between the volume of a gas at constant pressure and temperature is directly proportional to how many moles of that gas you have. So if you have a half a mole, you're going to have a half that volume. And what we're going to do tomorrow is look at the relationship of how we combine them together, or I guess, so the next section will be combining these laws together to ultimately get the ideal gas law. But today we're just focusing on these 3 individual relationships: pressure-volume relationship, volume temperature relationship and volume number of moles relationship, and then we'll combine them all together later. So I will see you tomorrow.